Okay, let's talk about deductive and inductive reasoning. We're going to talk about a third, but just briefly. But the main two that we need to learn are deductive versus inductive. So some definitions first. Deductive reasoning is reasoning based on postulates, theorems, and definitions. That's what we'll be dealing with as far as proving things goes. On the other hand, there is inductive reasoning, which is reasoning based off of past experiences. And we'll talk about those, but that's the definition. The third type that we're going to talk about very briefly is abductive reasoning, which is reasoning based on hypotheses. It's the scientific method, is abductive reasoning. Like, well, I have a guess this is why it's happening, this is what's going to happen, but I should run some experiments to figure it out. So, for instance, if we have the statement, if two lines in a plane do not touch, then they are parallel, since that is what the definition of parallel says. That is logic based off of the definition of parallel lines. So this is going to be deductive reasoning. It is based off the definition of parallel lines. It's not based off of anything else. It's based off of something that is proven and accepted to be true, off of nothing else. If two supplementary angles measure 3x and x, then x equals 45. This is also going to be deductive reasoning for several reasons. By the definition of supplementary, I know that 3x plus x has to equal 180, and by a little bit of algebra after that, we can solve x to be 45. So it's all or knowledge that we have before, not of the past, but of theorems and postulates and definitions and algebra and things like that. If the first three numbers in a sequence are 3, 6, and 9, then the next number is 12. This one is going to be inductive reasoning because we're basing our logic off of the fact that the first three numbers are 3, 6, and 9. Based off of that information, they're increasing by 3 each time, so the next number should be 12. It's based off of the past information of 3, 6, and 9. If it is cloudy at night, then it will be warmer. This is inductive reasoning. It's based off of past experience of warm nights. If the night is warm, then it's cloudy outside. There might be laws, but this is what I'm basing this off of. I'm basing this off of past experience. So I'm using inductive reasoning. If there's some sort of law or scientific statement that says, and I believe it's the greenhouse effect, if we use the greenhouse effect to say that clouds outside make it warmer, then that is deductive reasoning. So it depends on your path of logic, or your logic path, whatever you want to call it, depends on which reasoning you're using. Me doing this, I'm using inductive reasoning. If a substance burns green, then it is copper. Then there's copper in the substance. This is an example of abductive reasoning because based off of past experience, but it could be something else. So past experience, we know it is a scientific law that copper. Well, law. I don't know. It's science that copper burns green. If you throw a penny in a fire, it'll burn green. So it's kind of past experience, kind of science, but it could be something else. I'm sure copper isn't the only thing that burns green. There could be other things. So I can't say that it's theorems. I can't say it's past experience. It's kind of like a gray space between the two. So this is abductive reasoning. That's the third type. You really only need to know the first two, deductive and inductive. Those are the most common as far as geometry is concerned. So that's it.